Hey, physics! Wickham here. A pendulum is basically just a weight on a string. And I say weight because gravity is important. If you try and do this with zero gravity, nothing happens. But here on Earth, or any place with a reasonable gravitational field, you pull a pendulum back and you let it go and it swings. Back and forth and back and forth and back and forth with astounding regularity. So regular, in fact, that in 1656 Christian Huygens developed the first pendulum clock, and it kept time better than any other device at that time. Now, we are going to explore pendulums in physics as a way of introducing the idea of waves. Now, waves also go up and down, or back and forth, or back and forth. They have that same kind of what we call periodic motion. So this right here is periodic, meaning that it has a period, which was what we call the time that it takes to swing back and forth once. So one complete swing, there and back, takes some amount of time. That time, which is the characteristic of a pendulum, is called the period. And we give it the variable capital T. I guess maybe because it's an important time. And like all times in physics, it's measured in units of seconds in the SI system. Now, related to the time that it takes to swing back and forth, related to the period, is something that we'll call the frequency. Not how much time does it take to swing once, but how many swings do we get in a certain amount of time? Like how many swings per minute, or how many swings per second? Now, it doesn't make a whole lot of sense to talk about swings per second when we're talking about a pendulum, since it doesn't even complete more than one swing in a second, or barely more. And so it would be a fractional number of swings per second. It's sort of strange. But if you're into video games or video editing, then frames per second is a very important feature. And if you have fancy computer equipment, you may have seen a refresh rate in a unit called Hertz. That's Hz, named after Heinrich Hertz, the German physicist. 1 Hertz means that you have one repeat of something per second. A frequency, lowercase f, of 10 Hertz means that it happens 10 times per second. And so if we had a pendulum and it swung back and forth 1 time per second, it would have a period of 1 second, wouldn't it? If it swung back and forth 2 times in 1 second, it would have a period of 1/2 of a second. 2 swings per second, that's 1/2 of a second per swing. If we had a frequency of 10 Hertz, then it would take 1/10 of a second to swing back and forth. As you can see, there is a reciprocal relationship between these two, period and frequency, which we'll explore a little bit more later on. But for now, I'm curious about what affects the amount of time it takes to swing back and forth. What affects the period of a pendulum? To explore that, join me on the floor. Okay, what we're going to do is we are going to hang our pendulum right here and swing it back and forth and see how long it takes to go back and forth. We're going to find out what that period is. But trying to time one swing is not very easy because humans are bad at stopwatches. And so we're going to have some mess up at the beginning, some error, and then some mess up and error at the end, right? Which means that we're not going to get a very reliable number. And we could do a whole bunch of them and then take the average. But what's easier is to let it swing back and forth a whole bunch of times and then just divide that by the number of swings. That way we get all of those times together, but we're only going to be adding in our human error at the very beginning and at the very end, and not every single swing. And so what I'll do is I'll use my iPad down here to use my timer, and I'll record the time. Now we need some way of affixing this here, and we could tape it to the table, but you know, a lot easier is just to put something heavy on top. I got this jar of chickpeas here from my cabinet, and so, whoops. We'll just put that right up there on top, and that holds it in place. Right? And then I can change the length of this pendulum if I need to. I can swap this out for something heavier if I want to. So I'm able to swing this back and forth, and we'll time it. So I'll swing it back and forth. Let's start that. It's nice and regular. And so as soon as it comes closest to me, I'm going to hit start on my iPad. Okay, start. 1 swing, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Great. 19.77 seconds, it says, which means we have just about 1 second per swing. Now, we'll need a way to measure this as well. We could use a ruler or a tape measure, or if you have one of those fabric tape measures used for sewing often, then what's really nice is often the back side has centimeters. Not a lot of people have long tape measures at home that measure in centimeters, but you can measure in centimeters in the back. Now, when you're measuring the length of this pendulum, you really want to be careful that you're measuring from the point where it swings down to the middle of the pendulum bob, the weight down here. Not to the top, but to the middle of it. And that's important because that's where the center of mass is, and that's the part that we really care about, swinging back and forth. Okay, so, but for a pendulum, to make one, you can make it out of pretty much anything. Let's take a look then. All right, you need something as a weight. That could be a battery or eraser of some kind, even a rock. I used a socket from my basement. Worked out pretty well. You also need some string. You could use any kind of string you like. The thinner and lighter it is, the better it's going to be, but you don't want it too weak to hold up the weight. And to attach the two together, you can tie them off, or I just like to use a little bit of tape. That way you don't have to worry about knots and everything. I taped mine right to the side there, and it fed it up through the middle, and it makes a nice little pendulum. All right, so we know that the period of a pendulum is how much time it takes to swing back and forth, and now we know how to measure it. But we still have to figure out what affects the period of a pendulum. We're going to be exploring 3 different things. 1, how long the pendulum is from the pivot to the middle of the weight. 2, how heavy that weight is. Does a lighter one take less time or more time to swing back and forth? And 3rd, how large a swing do we have? Your instructions are going to be in this week's activity, but that's the idea. Explore these 3 things and see which one has the biggest effect, or any effect, on the period of a pendulum. Great! Good luck!